So in this video I'm going to show you how you can very easily link an LED on one of the MCP23017 pins. So the MCP23017 can either supply the power for the LED, or it could be used for syncing the power from the LED. So we can either have it as active high or active low. In this example I'm using it as active high. So here you notice I've got two DuPont connectors. One is going to the ground terminal and one is going to the channel PA0. So here you can see orange lead, and that is going from the ground, so I put it on the ground here on the breadboard. I then have the other wire coming from the channel A0 going to the positive on the LED, and then coming from the negative of the LED I have a resistor here. Now this one here is quite a high resistor, so you need to choose the right resistor for the voltages that you're working with. I would suggest around 330 ohms, and then I have a link coming from the other side of the resistor back to ground. So in the wiki, if you look here, you've got the MCP23017.MD. I would suggest you take a look at this because it does go into details of the issues around pins A7 and B7. So that's all explained here. And then also in the wiki feature, under the MCP, you'll find more details here where I go into the maximum current allowances for this device. So here, this is something you need to understand, and really you're looking for around 9.37 milliamps per channel, ideally probably 8 milliamps. Most low voltage or low current LEDs are probably only drawing about 2 milliamps, but this is something you do need to be aware of. So when we go into the GMRI CDI and for the MCP23017s, obviously this is for you having two devices. Obviously we're going to be showing here port 1A. So what we can do here is go into this type and we choose the channel type, and what we want to choose is output phase A. Now the wording of this has slightly changed from the previous version. This will appear in version 4 because there was confusion over what we had written there before. So in this case we're going to choose output phase A. But what you'll notice is you will have to click on save or write, and then if you click on write it does save it. Now if we scroll down a little bit here, clicking here more and on trigger will turn the LED on, or clicking on this one will turn it off. So what we can do is we can alter the duration time. So that was set at 0, so that's in steady state. So we could make it blink by setting it to 1 and setting this one to 1. So this is what makes it blink. Again, because this has a slider, you don't have to click on save. Now you can here click, and then you can use your left and right arrow keys to adjust the value. So that's a nice another feature. So by having it as 1, when you now use the trigger, the LED will now start to flash at this rate. But another thing you can do, so I'll just stop the flashing. What you might want is this to be 0, and maybe you want this to come on for a second or longer. So you can up the value here. Now what will happen now when you trigger it, the LED will come on for an extended value. So each one of these is adding 100 milliseconds. So in theory that now is 1000 milliseconds, which is a second. So that will just do a single pulse of it going on and then going off.